Section 9, Truck and Brakes. General, the Amtrak's bi-level cars are equipped with two axles, H-frame, two truck per car, and an electrical actuated air brake system. The two trucks on each car are disc brake and have two inboard mounted drive discs per axle. Each disc is braked by an individual pneumatically operated brake cylinder. Truck H-frame is welded in steel and construction utilizes a primary and secondary suspension system for the maximum passenger comfort and safety. The primary suspension for the individual damped coil springs. In addition, with each axle box is longitudinally laterally located from the truck frame means of two-leaf spring axle guiders. On the guiders are virtually frictionless axle guiding, which results in greatly reducing the maintenance and pre-calibrated stiffeners of the bushing connections of the leaf guiders of the wheel set, allowing the optimum tracking of the axle negotiating curves designed for the primary suspension permits rapid wheel changing replacement and elastomeric bushings. Second, suspension consists of a spring plank supported by the truck frame, adjustable swing hangers, and turn spring plank supported two air springs onto which is mounted in the truck bolster. The air spring suspension using one leveling valve per truck regulates the height of the car above the rail after the suspension is obtained with the brake control unit. In the level car, the side-to-side imbalance is catered by the adjustment of the torsion of the bar. The torsion of the bar, whose main function is controlled body roll, is connected between the bolster and the truck frame across the girders. The brake equipment of the bi-level car is two-pipe electrical pneumatic systems. These cars are hauled in locomotives with pneumatic control valves with provisions of electric train-like control actuation. The result of pneumatic braking applications that are electrically initiated released simultaneously at each of the car or the train. The main air high pressure reserve is supplied with the train line pressure through the car supply line. It receives the air pressure from the locomotive air compressor, maintains a supply reserve of 130 to 150 psi. Supply reserve through the brake control provides the air utilized watering system, auxiliary brake pipe, and the truck leveling valves of the truck air spring. When the brake pipe is pressurized, the brake release converses. When the brake pipe is depressurized, the brake apply. When the brake apply application is initiated, the locomotive control responds to the brake pipe pressure reduction. The rate of the reduction determines whether the required braking application is in service or emergency. This reduction occurs essentially simultaneously on all the cars. Electro-pneumatic is exercise. However, event of the electrical failure, the brake pipe pressure reduction initiated the brake control valve of the locomotive will cause the pressure valve to be transmitted through the train, which will result in rapid serial braking action application at the end of the train. The train emergency of the brake applications initiated with the locomotive from any of the three emergency valves, either the two brake application valves, each of the cases, the control unit reduction relay, the respondent on each of the car of the train, causing the stop of the emergency ray. Reserve of the filled and directed from the core supplies the regulated air pressure, the car water tanks, and the water raising system. The electro-pneumatic wide oil slide system incorporated with the truck take the advantage of available adhesion, minimizing stop and distance, increasing wheel life. 9.2. The trucks. The trucks are a bi-level car. Their outside bearing type of the incorporating welding frame, the swinging links incorporating the features. Adjustable swinging links adjustable to obtaining correcting spring plank height. The torsion bar, the control of the car body roll, hard hydraulic shock absorber, damp oscillation, primary and secondary lighter suspension, primary suspension control wheel, rear rail interaction. Primary suspension consists of a helicoil spring applies the wheel sets located in leaf spring guiders. The secondary suspension is a car body passenger weight air springs car leveling system that maintains the end level position relative to the track. The B end of the track incorporates the handbrake control cables connected to two air brake actuators, one per axle, to apply to the release handle. Back out of this one sec. Here is your overall truck assembly, starting with the truck bolster, the dump valve assembly, the side bearings, the center plate, the brake disc, the wheel set, the track frame, the lateral stop, torsion heel, Safety hanger, um, truck identifier plate, secondary suspension spring, secondary suspension vertical damper, ground cable, grounding cable, spring plank, wheel side sensor wiring, leaf spring guider, primary inspection of the damper, wheel bearing, slide prevention system wheel slide prevention system tooth ring, primary spring, an axle box identification plate, the lifting point, the spring planking connection tube, the brake cylinder piping, the brake caliper assembly, the disc pad, and truck baluster once again. 921 leveling valves. One of the leveling perfect truck with the effects of the variation of the heat of the air spring due to the increased passenger load and adding exhaust of the air springs to the maintaining the car body floor height. The leveling valve does not automatically compensate for the reduction of the floor height of the wheel wear to react to the small amplitude of truck movement. The choke of the bendage cutout cock of the leaving valve of the airline in the air truck. Each truck prevents a rapid air loss from the car in case of the air spring rupture. 922 the air springs. The secondary suspension of the bi-level car is provided by the pair of air springs at each side of the truck balusters, and each of the pair of air springs is connected by either a damping orifice or reserve forming part of the suspension system. Other orifices resistant to the transfer of air between the air spring and the reserve provides the vertical damping. An auxiliary secondary suspension provides the steel spring support on the car body in case of the air spring failure. The auxiliary system permits the safe operation of the car. 9.3 the brakes. The following description of the principal systems operating components of the brake system of the Amtrak bi-level car. Each bi-level car is pneumatically controlled by the brake system, which provides electrical train line control assist to the applicable or is capable of making service emergency applications releases. With this system, pneumatically brake applications are electrically initiated, released, and simultaneously at each car. In the event of the electrical failure, the brake control will functionally normally as modern pneumatic system. Service brake application controlled by the locomotive engineering brake valve. The voice for the brake valve releases the position of the brake pipeline is charged in the locomotive main reserve 130 to 150 psi as the pressure of it 110 psi. The brake valve is placed in brake positioning minimum service full service suppression handle off for emergency to separate the braking functions as initiated. The braking pressure of the brake piping is reduced along the training of the portion of the amount of the braking effort called for. Simultaneously above they apply to the energy to apply the magnet valve of the brake control unit, which initiates the simultaneous reduction of the brake pipe pressure of each car. Here's an Amtrak bi-level pneumatic brake system. I'll see if I can't zoom in. It's very complex. I can't read. The text is so small I can't read it. But, continuing. 26 service control valve in the brake control unit. Sensitive to the amount of the pressure reduction vents of the airs of the J1 relay valve of the pressure conversion of the reduction of the brake pipe upon the activation from the 26C valve. The J1 relay valve takes the air from the car, supplies the reserves, and increases the rate, allowing the pass of the large orifice before directing the brake cylinder supply to 72 psi maximum service 85 psi emergency. When emergency engineering brake valve is placed in the release position, the 26C valve vents in the output atmosphere air for the J1 relay from the brake cylinder line does likewise. Simultaneously release magnet is energized, allows the main reserve line to charge the pipeline. The electrical assist for each assist for the locomotive braking, all allowing controlling pipe and the air pressure, which leads to slower response time. Leakage of the air main reserve has no immediate effect on the braking system. The brake pipe remains fully charged if the main reserve line from the locomotive is disconnected. Therefore, the brake pressure is greater than the main reserve pressure is a check valve of the 26 control valve allows you to air to flow through the brake pipe, and this car supplies reserve. When the main reserve pressure is greater than the brake pipe, the the pipe pressure no flow occurs after the brake application supplies the reverse reservoir pressure reduces to that of the brake line of at 110 psi fully charged. If the main reserve pressure line is low and it has disconnected electrically, electrical assistant function must be inoperable. Brakes will be made applied for the end of application. Brake pipe is charged through the magnetic valve of the main reserve line. 9.3 braking control units. The check valve right here with the KMT vent valve. The check valve to the governor portion is in these two manifolds, which we'll go on the top left one first. Dirt collector portion, cutout cock, release magnet cock, application magnet cock. These are usually the brake control units. See this in the front of the locomotive with the glad hand and everything. The 24 control valve service portion, the J1 relay valve, the 83 cubic inch volume, application release magnet valve portion, and circuit. When the engineer breaks this valve, then place an emergency position of the vent valve. The brake initiates the emergency rate of the brake pipe reduction of the brake pipe, in which case the MKM2 valve each of the car connecting directly to the brake pipeline. The AM2 valve is senses the emergency rate of the brake pipe pressure reduction of the vent of the brake pipe air of the large orifice during the atmosphere. So you got this KM2 valve letting it an emergency position. Electrical assisted function merely reduce the pipe pressure to the 20 psi, initiate the full service brake application during the emergency application. An emergency brake application initiated with the conductor valve. The conductor valve is connected with the brake pipe line through the E3. E3 basically consists of a spring-loaded piston, the pressure on either side, which is equalized and interlocking small orifices. The conductor valve is operated with the pressure connecting the E3 valve is vented to the atmosphere. Suddenly, the pressure of the reduction of the piston allows the brake pipe to raise the piston as exposed an orifice connected directly to the atmosphere. The brake pipe air directly to the atmosphere to the emergency rate of the turn of the activities of the KM2 valves. The auxiliary air supply. The auxiliary air supply device taken by the auxiliary supply reserve before entering the auxiliary line. Air flows to the governor valve, which supplies the pressure falls below 80 psi, cuts off the air supply to the auxiliary line. And 941 wheel slide control. The wheel slide direction detection system receives the pulse count supplies each of the four magnetic sensors. It must, if the pulse contact between the axles becomes sufficiently different, the wheel slip down valve of the affected truck of the energize the brakes of the truck release. When the wheels regain proper retentional speed, return to the pulse control normal. The wheel slide dump valve is de-energized when the system includes the provision to prevent the synchronized slip of the axles, monitoring the deceleration rate of the one axle. This rate exceeds the set of the valve. The brake pressure is released by the truck of the synchronizing is broken. Also, safety circuits restoring the braking and the venting of the dumping valve and continuous energized for the more than 3 seconds. Compensation to provide adjusting detector for the wheel side variation due to the wear. Electro wheel supplied collector shown in the figure 9.4 receives a single pulse counting the magnetic sensor. This compares the pulse counts of the one wheel, the pulse counts of the other wheels. If there is no side of the count, should always be the same, whereas the wheel sliding will less than be counted the sliding wheel for those of which are not sliding. The method detecting the wheel sliding is shown in figure 9.5. Here you see 9.4, the wheel slide control schematics. The controller Note the controller is located in the electrical locker. The capacities A, B, and C in the front of the B end with the side gimmick of a wheel slide valve, wheel slide dump valve, and through a cable connector to the junction box of the cable receptacles going into the on both sides of the A and B side, with A, B, and C receptacles going from the 4 marked spots, which detect the which are the cable receptacles that test for the braking, I guess, the wheel slippage when it's the different speeds. The cable receptacles go into the cable connector junction box, and from the conjunction box out of the 4 spots of the wheels that they test on each A and B side goes into the wheel size selector control N5621B test lamps of B and A switches. This is wheel slide control wire schematic from Figure 9.5, it be seen that one wheel puts the pulse on 60 counts, or whether that it being compared to the pulse of 63 counts, the counters of the property, the number of the counts of 60 is reached, the signal appear to the counter output of the signal will stay until the counter is reset, and having a signal appear at the reset the terminal. Note that the 60 counter sends is opposite of the reset terminal in both itself the 63 counter, therefore the wheels move evolving the same speed higher than lower. The 60 counter will fill up and make an output turn on that both input, both itself and 63 counter, but back into the zero. Resetting the counters back to zero turns off the output of the counter and allows the counter processing to start over. Then on the non-sliding 60 counter, it will always count to 60 and start both over and count to 60 again and start both over and again and so on. However, the event of the first axle slides as soon as the axle is turning more slowly than the second axle. The 63 count will fill. They send it to the opposite of the wheel slide relay before the 60 counter can fill and start both over again and over again. Of course, the detection system could not only detect side one on axle number one, other detectors connected between the other axles in order to detect the slides of these axles, so that the total 4 detectors, like one illustrated, are required of the present of the electrical system. And in the event of an uneven wheel, whether there can be a time that when the wheels are truck are significantly different, the diameter for the wheels on another end is in comparison to wheel travel, that it may be made. A sensitive slide system may be changed indirect against the 4 position counting switches, including the electronics. Each switch in the position of the letter A, B, C, and D in the gauge is supplied to the appearance similar to the wheel. Inspector the thickness of the gauge inspected instead of measuring the thickness, and is measured the thread diameter. The gauge is considered the A, B, C, or D. The wheel car is the wheel shop. Only the time return of the wheels are placed under the car. Inspector takes the gauge and notes that the wheels are A, B, C, or D, or gauge individually. Then they set to the corresponding switch of the position of each axle. The electrical wheel control that you see on axle 1 and axle 2. Axle 2 pulses at 63 on slip-on number 1, which axle 1 goes into, and there's 2 other detectors. The axle one pulses into the resets the counters at 60 counts, and then the 63 counts in the back axle, with the axle pounce and the slip-on number 1. Shows the 63 count is a slip-on number 1. Operate the wheel side relay A track. Since the digital rather than the analog system, no necessity calibration made to a reading of the fine tuning again of any kind. Nowhere is it ever any necessary to reset calibration switches between the wheel turnings, because the amount of the wheels between the wheel turnings is only 1/2 an inch. The system will operate successfully that much difference between the wheels without necessary to change the compensation switch position and necessary to protect the dump valves of the valve false energization. This because of the failure of the wheel slide system energize the dump valve for an extended period of time. The braking car would be reduced by 50%. The protection system consists of 3-second times begins timing whenever the dump is energized. Will turn to the dump valve. After 3 seconds, this will reset the dump valve signal and is remove the remaining unaffected temporary fault under the wheel system. At the same time, the non-effective valve performance of the very bad dump signals and percent of perhaps a second. The only brief removed, reapplied perhaps another seconds continually through the stop. The system also protects against synchronized slide, limiting deceleration on one axle to 8 miles per hour per second. Thus, the axle should attempt to decelerate synchronized to excess of the rate. The brake of the one axle should be removed, which would break the synchronism between digital detection section of the function in the normal manner. 942 water raising system. Air flows from the auxiliary line of the water tanks through the pressure reducing valve. The pressure reduces 130 to 150 psi to 40 psi. The supplies also feeds the buffer volume of 40 psi. The line contains a safety valve to prevent over the pressure water tanking and cutting out cocks of the depressurizing the tanks while filling in the inside of their car. The air pressure of the governor portion located in the brake control unit under the port 1, adjusting, reducing the valve. The valve prevents air pressure supply to the water tank determined the valve because of the controlled air pressure to supplied to see figure 9 to the end, and an output to the port number 2, water raising the air reserve. The reservoir is used to store air for the use of water raising system. Another outlet is port 3, which goes under the water tanks. E1 of the safety valve prevents excessive air pressure in the system. The safety valve in the set at 5 pounds above the governor portion setting. Here is an overall truck view. You have your truck bolster, your dump valve assembly, side bearing, the count center plate, the brake disc, the wheel slippage, the track frame, lateral stop, the torsion head, the safety hanger, the truck identification plate, the secondary suspension, air spring, the secondary suspension, vertical damper, the ground cable, and the spring planking, and the wheel sliding wiring, the leaf spring guidance, the primary second suspension diaper, the wheel ring, hill sliding, providing teeth wheel, primary spring angle identification, lifting point, spring plank connection tube, brake cylinder piping, brake caliper assembly, disc pad. And here you see the cable torsion bars, hangers, lateral stops, and cable assembly guides. This is an H frame. Gives on the arrows A and B is followed by the parts of 1 through 30, and the view of the indirection of the airflow, the view direction of the arrow B. So you got your side frame cast, your H frame with the center plate. Side frame goes on. This looks to be like a journal case sliding in through the arrow point of the B. And the direction of arrow A is underneath. Here's a description of the truck frame complete world mints. This shows the part numbers and the drawing numbers and the figure indexes. This is another truck drawing with the primary suspension assembly. You see the side came fast with the bolster springs, inside bolster springs, the cover in the seats to the inside of the axle mounting frame with the laps, and this truck truck basically left and right bolster springs for each underneath the truck, holding up the wheel journal cases. Here's another picture of figure primary suspension assembly. You got your laps, you got your side bearing, spring inside, wheel journal case going around that. The wheel journal casing suspension shown in the arrow A, the view of the direction. Another list of NSN's parts. Bolster spring plank assembly. This is the center plate, the center casting plate. These are 1410. What is 1410? The 140. The nut hexel. You have your center boiler, the center plate, the drafting gear public thing right here. This is there's wheel adjourning bolts. You have your side pump and your bottom overlaps spring plank assembly. This is a bolster with a spring plank assembly with number more pictures of that. This has a wheel journal bearing for that. Imagining the Amtrak is a little different from the maintenance car railway that I've looked at. Once again, suspension, air brake. This comes down to the air brake valve, air compressor valves or whatever, and cylinder. This here is a valve for the center journal bearings, bolster pings, B end of the truck. This is the A end of the truck. Same center bolster with the two big old things around there. I guess those are springs underneath the laps. This is the side frame, bolster frame assembly. You have your spring lap right there. Your spring lap vertical adjuster. You got all the detectors and stuff on there. Another picture of the bolster frame assembly. Figure 8 actuator piping of the handbrake cable. That's right up under the wheels and center brake. Here is a wheel slipping nameplate. Nameplate details. This is the air spring, which is underneath the center bolster. For wheel axle and detail. See, the journal case pulls out of the axle with the journal in itself with the wheel disc. These are a caliper assembly. These hold together the piston, spring pistons. This right here is a actuator with a handbrake. Actuate the handbrake or without the handbrake. That goes actuator with the handbrake. Reserve and dump valve assembly. Cable assembly of the car body junction to the dump valve. Cable assembly car body junction with the dump valve. This right here is a level valving assembly. And that is all.